High-protein diets have become a cornerstone of modern nutrition trends, lauded for their ability to support muscle growth, promote satiety, and enhance weight management. From bodybuilding communities to weight loss programs, increasing daily protein intake has become almost synonymous with health optimization. Yet, as with many popular dietary strategies, emerging research suggests that there may be complexities beneath the surface, particularly regarding kidney function and the long-term management of nitrogen waste. While high-protein eating patterns are not inherently dangerous for healthy individuals, the body's handling of excess protein can create subtle stresses, particularly in those with mild pre-existing kidney conditions, and understanding these mechanisms can help optimize diet choices while preserving long-term kidney health. Protein is unique among macronutrients because, when metabolized, it produces nitrogen-containing byproducts that the kidneys must filter and excrete. This process primarily generates urea, which is transported through the bloodstream and eliminated in urine. In healthy individuals, the kidneys are remarkably efficient at managing this load, and short-term increases in protein intake rarely produce harmful effects. In fact, many studies highlight benefits such as increased lean muscle mass, better appetite regulation, and improved body composition. However, research increasingly indicates that when protein intake is consistently high over long periods, the increased nitrogen load can subtly elevate glomerular filtration rates, GFR, essentially the rate at which the kidneys filter blood. While a higher GFR can initially reflect an adaptive response, it may also indicate an increased workload for the kidneys, which could be significant over years or decades, especially in individuals with pre-existing vulnerabilities such as mild chronic kidney disease, hypertension, or diabetes. New studies exploring high-protein diets shed light on both potential risks and adaptive mechanisms. For instance, some researchers have observed that sustained high-protein intake can increase the production of urea and other nitrogenous compounds, which in turn may slightly alter kidney hemodynamics. While these changes are generally manageable in otherwise healthy adults, they could accelerate the progression of kidney stress in individuals with mild dysfunction. Importantly, these effects are typically gradual and often asymptomatic, which means they may go unnoticed until routine blood work or urine tests reveal early indicators such as elevated blood urea nitrogen, BUN, or microalbuminuria. The subtlety of these changes underscores the importance of monitoring kidney function when adopting long-term, high-protein dietary patterns, particularly for populations already at risk. At the same time, there is strong evidence that high-protein diets can confer meaningful health benefits, especially when combined with balanced nutrition and adequate hydration. Protein-rich meals enhance satiety, which may support weight control and reduce the consumption of refined carbohydrates and added sugars. Improved body composition and muscle mass preservation, particularly in older adults, are also well-documented advantages. Muscle tissue is metabolically active, and maintaining lean mass contributes to better glucose regulation, enhanced energy expenditure, and reduced risk of frailty. From a cardiovascular perspective, some research suggests that substituting protein, especially from plant sources, for excess refined carbohydrates or saturated fats can improve lipid profiles and lower risk factors for metabolic disease. Thus, while protein metabolism places additional demands on the kidneys, the systemic benefits often extend to multiple organ systems, including metabolic and cardiovascular health. One positive perspective emerging from recent research is the adaptability of the kidneys themselves. Healthy kidneys can compensate for increased nitrogen loads over extended periods, maintaining homeostasis without long-term damage in most individuals. This adaptive capacity is enhanced by adequate hydration, which helps flush excess nitrogen and prevent the accumulation of potentially harmful metabolites. Moreover, the source of dietary protein can influence how the body responds. Plant-based proteins, which generally produce lower nitrogen waste per gram compared to animal proteins, may reduce the kidney workload while still supporting muscle synthesis. Lean meats, fish, eggs, dairy, legumes, and soy-based proteins all contribute valuable amino acids, and varying protein sources can help balance nitrogen metabolism while supporting overall nutrition. For individuals with mild pre-existing kidney conditions, recent studies emphasize the value of a tailored approach. Moderate protein intake, combined with regular monitoring of kidney function through BUN, creatinine, and GFR measurements, allows for the continued benefits of high-protein diets without overtaxing renal systems. Interestingly, research indicates that even in these populations, a thoughtfully structured high-protein diet, especially when paired with adequate hydration and balanced macronutrient distribution, can still support muscle preservation, weight management, and metabolic health. The key lies in personalization. Rather than adhering to extreme protein regimens, individuals can optimize intake levels, diversify protein sources, and integrate regular kidney function monitoring as a proactive strategy. Another encouraging finding from recent literature is that high-protein diets do not uniformly accelerate kidney dysfunction, and in many contexts, they may actually support metabolic resilience. For example, in older adults at risk of sarcopenia, adequate protein intake helps maintain muscle mass, mobility, and quality of life, which indirectly protects cardiovascular and renal health. Similarly, for athletes and physically active adults, higher protein intake supports recovery, performance, and energy balance. In these populations, the short-term increase in renal workload is offset by broader systemic benefits, including improved glucose regulation, better body composition, and enhanced overall functional capacity. Ultimately, the emerging evidence paints a balanced picture. While high-protein diets can place additional demands on the kidneys, these effects are generally manageable in healthy adults and can be mitigated with strategic planning, hydration, and source selection. Even in individuals with mild pre-existing kidney conditions, personalized approaches that moderate protein intake and monitor renal markers allow the continuation of the benefits of high-protein diets without significant risk. The narrative is not one of alarm but of careful optimization. Understanding how protein metabolism interacts with kidney function empowers individuals to enjoy the muscle, metabolic, and satiety benefits of high-protein diets while preserving long-term renal health. Rather than viewing protein as a potential danger, it can be reframed as a powerful nutritional tool that, when used thoughtfully, strengthens multiple aspects of wellness, supports functional longevity, and aligns with individualized dietary needs. By integrating awareness of nitrogen metabolism, hydration, and diverse protein sources, high-protein diets can be safely incorporated into a sustainable lifestyle. These insights highlight a larger principle in nutrition. Personalized, informed strategies often maximize benefits while minimizing potential stressors, allowing individuals to harness the advantages of contemporary dietary trends without compromising key aspects of health, such as kidney function. In this sense, protein is not a risk factor to fear, but a nutrient to manage intelligently, reinforcing the broader notion that evidence-based diet customization is the cornerstone of long-term wellness.